Help you understand the process better, we're going to tackle the completing the square the long way round this first time so that you get an idea of why and how the short way works. So the first thing that you need to understand when it comes to completing the square is that you need to have it in the correct starting format, and that means that it needs to be equal to 0. And it means that it must be just an x squared at the beginning, no number in front. So let's sort that out with this one here. So the first thing we're going to do is make it equal to 0. So that's about taking the 8 off both sides. So that'll take us to 2x squared plus 12x. And then we're going to have minus 14 equals 0. So I've made it equal 0. Now we're going to, in this case, in a very simple way, get rid of the number in front of the x squared. Because everything's even, we're just going to divide through by 2. Later on, I'll show you what to do if it's more complex than that. But for here, we're just going to divide through by 2. So we'll have x squared plus 6x minus 7 equals 0. So we're not going to factorise in the normal way. This is where the completing the square comes into its own. So the first thing we're going to do with completing the square is write down the square part. So for this particular one, the square part looks like this. So let me explain where it's come from. So how did I know what to write down? It's always going to be an x at the front. And then this number here is always going to be half of the number in front of the x term that you start with. Okay, so to better understand how this links to what we started with, we're going to expand our brackets here. So this is the same as x plus 3 brackets x plus 3. And if we expand that, we're going to get x squared plus 3x plus 3x plus 9, which if you simplify gets us to x squared plus 6x plus 9. So you can probably now understand why we're halving, because look at what's happened here when we expanded. Now, x squared plus 6x plus 9 is not what we started with, and so that's where the concept of having to complete the square comes from. So x squared plus 3 in brackets squared gives us this. We want it to actually equal just this section. And so what we'd need to do is take off 9 to get rid of that extra bit that we don't want. So x plus 3 squared minus 9 now is exactly the same as the part that I've underlined in our equation above. So we then just tack on the minus 7 equals 0. Tidy that up a bit and we get x plus 3 in brackets squared minus 16 equals 0. So that section that we've just done, that's the completing the square element. Now sometimes, but not always, you will then be asked to actually solve the equation that you had. So I'm just going to show you how to do that on this example. So x plus 3 squared equals 16 if we add 16 to both sides. So now we can square root both sides, which will give us x plus 3 on this side, and on this side it will give us plus or minus 4. Remember what happens when we square root. So now we've got two possible answers. The first one is x plus 3 equals 4. And if we solve that by taking 3 off both sides, we get x equals 1. And the other possibility is that x plus 3 equals minus 4. And again, if we take 3 off both sides, that leads us to x equals -7. As I said, it's not always the case that you'll have to do the solving. Let's look at another example. Now you'll notice with this one it doesn't have an equals 0 on the end, and that's not uncommon in questions. So this is just an expression. We're not going to solve it as such, we're just going to put it into the format. Now sometimes they might use the words completing the square, other times they might just say that you need to change it into the format that looks like this. Now they're often a bit sneaky and put a plus there. Sometimes it could be a plus, but obviously b could be a negative number depending on what we find out. So we're now going to look at how we can shorten the process that I showed you on the first example as well. But the first step is going to be exactly the same. So we're going to form up our squared bracket. Remember, we know that this part here is always just going to be half of whatever is here, including the sign. Now, what we had to do last time, remember, is to complete the square, we had to adjust it, because remember when we multiplied out the brackets, we had an extra number that was more than what we wanted for here. Now that extra number is always going to be the square of this part here. Let me just take you back to the previous example so you can see that. So we had a 3 at the end of this one, and look, we ended up with a square of 3, 9 at the end here. So it's always the square. Let's go back to the example we're doing. Okay, so that means I would have an extra +4 on the end of this when I expand it. So I'm going to take off 4 to correct that, and then we put in the +11 that was there before. So let's tidy that up now. So we've got x minus 2 in brackets squared plus 7 would be our final answer here. Let's look at another one. So this is bringing up a different problem, because you'll notice that it's breaking one of those rules that I talked to you about, and that is the rule that we can only have just x squared on its own. And because it's not an equation this time, it's just an expression, I can't get rid of that -1 by just multiplying or dividing, because I don't have two sides, I don't have an equals 0 that would allow me to do that. So we need to get rid of it, but we're going to do it by factorising instead. And we're only interested in working on this section, remember, to start with. This is the bit that we do the completing the square on. So I'm going to factorise that to bring out the minus. So that could be written like this. Now, just be careful, that is not the completing the square. We're now going to do the completing the square on what's inside those brackets. So leave the minus out there and let's have a big bracket this time. So if that x squared plus 8x is what I'd have, then my squared brackets would be x plus 4 in brackets squared. And then I'm going to have to take off the extra bit, which remember is always the square of this number. So that's going to be 16. And all of that needs to sit in those big brackets, because everything in the square brackets is the same as x squared plus 8x. And then we tack on the -11 here. Okay, so now we're going to remove the brackets and see what we've got. So we'll have minus x plus 4 in brackets squared, but now we're going to have plus 16 minus 11. And if we tidy that up one step further, we're going to have plus 5 here. And the thing that people get wrong most of all is that this section here They neglect to put the brackets round, and then when it comes to actually working things out, they would have left the minus 16 as minus 16 and not realised that they needed to multiply it by that minus 1 that was out the front. So that's how we've tackled the fact that it wasn't just x squared. And I'm going to do another example that requires the same sort of technique here, but another step up. So you can see in this example, it's also not just x squared. It's not an equals example, so I can't divide through to get rid of it. But we're going to factorise it out again. But remember, we're just focusing on these first two bits to start with. The number on the end just gets left there till towards the end. So I need to get rid of the 9, so that's what I'm going to have to pull out. So that's going to be 9x squared. And then over here, we're going to have 12 divided by 9. So 12 divided by 9, if we simplify that a bit, we'll get 4 over 3. I know you don't like it, but it is what it is. So now we're going to do the completing the square on the part in the bracket. So remember to keep that 9 outside. So our square brackets are going to be x minus 2/3 in brackets squared this time. And then we need to take off 2/3 squared. So we want 2/3 all squared, and you can just do this separately by squaring the top and the bottom. So that becomes 2 squared over 3 squared, which is 4/9. So we need to take off 4 over 9. Let's bring down the +1 so we don't forget it. So let's remove our brackets now. So we're going to have 9 brackets x minus 2 over 3 in brackets squared. So 9 times 4 over 9 is actually going to just give us the 4. So that's going to be minus 4. And then we've got +1. So final tidying up leads us to having -3 here. Now we're going to have a look at why we might have bothered doing this, completing the square, especially if it's not to solve an equation. So one of the main reasons why you might do this is to find what are known as the turning points, or the minimum and maximum points of a quadratic curve. So this first example I'm going to show you is going to find the minimum point. If we were to So this one has already been completed. Completing the square element has already been done to this. If we had it back at its original form, we'd see it as a quadratic expression, and we should be aware therefore that it would be that shape of a curve. So we're looking to find the coordinates of that minimum point there. If y equals this, which is this curve that I've drawn to the side, the minimum possible value it could be is when this is the minimum possible value it could be. There's nothing you can do to change the -3 without cheating. So it's only by minimizing this section here that we're going to be able to get our minimum value. Now, this section here is a squared section. And so because it's a squared section, it can never be negative. And so the minimum that this could ever be is 0. And therefore the minimum that y could be would be 0 minus 3, which is just -3. So we've got our y coordinate. So we need the x coordinate to go with it, and the x coordinate has to work so that 3x minus 2 equals 0, which is the minimum that bracket could be. So if we solve that, we get 3x equals 2, which means x equals 2/3. So the coordinates of this minimum point over here are 2/3 and -3. Let's do one more example. This one is going to allow me to show you how you might use the same sort of idea but to maximise instead. So if we were to expand this back to its original form, you'd find that this had a minus in front of the x squared term, which means that in terms of drawing it as a graph, it would look like this, and therefore it has a maximum point and not a minimum point this time. Same idea. If this is y equals this is our curve, and we want to maximize it, then we've got 5 take away this amount here. So to maximize the value of y, we again want to minimize this part here. And as we looked at before, because it's a squared bracket, it cannot be less than 0. It can't be negative. And so we want that to equal 0. So y equals 5 minus 0 will be our maximum, which means y will equal to 5. And again, to find out the x coordinate goes with that, we're going to have x plus 4 equals 0. Therefore, x equals -4. So the coordinates of this maximum point here are -4, 5.